They told us Antarctica was always frozen, always barren, always dead. They were wrong. I'm going to show you something that changed everything I thought I knew about this planet, about our history, about who came before us and what they built. And I'm going to do it with maps, with expedition logs, with ice core data that should have rewritten every textbook on Earth and somehow, quietly, never did. Start with a single map, 1513. An Ottoman admiral named Piri Reis, working in Constantinople from source charts he described as ancient, older than any European tradition of cartography, draws the bottom of the world. A coastline, bays, inlets, mountain ranges, river systems. A coastline that wouldn't be confirmed until 1958. Not approximated, not guessed. Confirmed by instruments and satellite technology that didn't exist in 1513 or in whatever era those original source charts came from. The official explanation is a lucky guess. A lucky guess. And that's where it starts. That's the first crack in the official story, because once you accept that a 15th century map accurately depicts a subglacial coastline buried under 2 miles of ice, a coastline only visible when that ice didn't exist, only one question matters. When was Antarctica green, and who was there to see it? 1898. The Belgian Antarctic Expedition. The ship Belgica, commanded by Adrien de Galache, becomes the first expedition to overwinter south of the Antarctic Circle, not by choice, but because the ship becomes trapped in pack ice in the Bellingshausen Sea. They are there for 13 months, and several crew members go insane. This is documented. This is in the official record. Frederick Cook, the American physician aboard, the same Frederick Cook who would later claim to have reached the North Pole, Cook documented the psychological deterioration of multiple crew members in clinical, methodical detail. The official explanation is polar madness, the effect of extended darkness, isolation and cold on the human psyche. And that's where the Belgica becomes impossible to ignore. Because Cook's medical logs, the full unedited versions, not the excerpts that appear in popular histories, describe crew members who were not merely depressed or disoriented. They were seeing things, specific things, things beneath the ice when the light conditions were right and the ice was thin enough to be translucent. Cook describes one crew member, a Norwegian sailor named Tollefsen, who became convinced he could see structures beneath the surface, not geological formations, not refracted light playing tricks. Structures, patterns, things that had been placed there. Now, I am not telling you Tollefsen was right. I'm asking you to consider what he thought he saw and why that specific hallucination, if it was a hallucination, would manifest in a way that was detailed enough, consistent enough across multiple crew members that Cook felt compelled to document it clinically rather than dismiss it as simple delirium. The deeper I went into the Belgica records, the more I noticed that the crew members who experienced the most severe breakdowns were precisely those who spent the most time at the ship's rail looking down through the ice. Not the ones huddled below decks, not the ones suffering the worst frostbite, the ones who looked. What were they looking at? The silence was deafening. Let me introduce you to Ernest Shackleton. You know the name. Everyone does. The heroic British explorer, the endurance expedition, the dramatic rescue. He's been safely mythologized, made into a story about survival and human courage that never asked uncomfortable questions about what he actually saw. But Shackleton kept logs, detailed, compulsive, exhaustive logs, and his team kept diaries. And buried in those diaries, between the navigational data and the descriptions of frostbite and the rationing of biscuits, are descriptions that the biographers tend to gloss over. Descriptions of anomalous terrain, of valleys sheltered oddly warm that the expedition passed near but was ordered not to investigate, of geological formations that one member of his crew, the geologist Raymond Priestley, described as showing signs of recent erosion by water in areas where no liquid water should exist. Recent, his word, not mine. Priestley was not a man given to speculation. He was a scientist in the most rigorous tradition of Edwardian empiricism. When he wrote recent, he meant it in geological terms, not millions of years, but perhaps thousands, perhaps less. And then there are the dry valleys. The McMurdo dry valleys sit just west of McMurdo Sound, and they are, by almost any measure, the most alien landscape on Earth. No ice, no snow, exposed rock and ancient lake beds, some of them containing liquid water year-round, despite the Antarctic temperatures, kept unfrozen by the salt concentration and by geothermal activity that the official models categorize as minimal. The valleys cover roughly 4,500 square kilometers. They are not a small anomaly, and here's what the official explanation says about them. They're dry because the surrounding mountains block the flow of glaciers, and the wind conditions create a katabatic effect that evaporates any precipitation before it can accumulate. Fine. That explains the current state. It does not explain what's in the soil. The soil of the McMurdo dry valleys contains nitrogen, phosphorus, organic carbon levels that are inconsistent with a region that has been frozen and lifeless for the timescales currently proposed. To have organic carbon in those concentrations, you need biological activity, sustained, productive, recent biological activity, not microbial, not marginal. The evidence suggests something much larger. Let me tell you something that doesn't make the front page of Earth Science journals, even though it probably should. When researchers drill ice cores in Antarctica, and they drill a lot of them, hundreds of cores going back hundreds of thousands of years, they don't just find ice, they find things inside the ice. Pollen, spores, organic compounds. At the deepest level, some cores have returned concentrations of fossilized plant material that don't match the surrounding geological timeline in ways the mainstream narrative finds comfortable. Beech forests, ferns, subtropical vegetation. Now, the official scientific position, and I want to be clear, I'm not dismissing science wholesale. The official position is that yes, Antarctica had lush forests, but this was 60 to 100 million years ago, during the Cretaceous period, when the continent sat in a warmer position and the planet itself was dramatically hotter. This is not controversial, fossils confirm it. Fine. But here's the strangest part. Some of the organic material found in certain ice core samples, particularly from drilling operations conducted by the Soviet Antarctic expeditions in the 1970s and 1980s at Vostok Station, and more recently near the Wilkes subglacial basin, appears to suggest biological activity that is far more recent than 100 million years. The precise ages are debated. The studies are published in narrow specialized journals with limited circulation, and when researchers begin pressing for more sample access, the samples become unavailable. Not lost, not destroyed, unavailable. Why? And what exactly did the vegetation look like? Because there's a difference, a crucial, staggering difference between fossilized Cretaceous plant material compressed and altered beyond recognition over geological time, and plant material that still shows cellular structure, that still retains enough biological information to identify it as something that was alive relatively recently, in a place where nothing should be alive. The pattern repeats with unsettling precision. In 2017, a research team from the University of Canterbury published findings from sediment cores drilled in the Ross Sea right off the coast of West Antarctica. What they found in those sediment layers, approximately 400 meters below the current seafloor, were pollen grains, fossilized roots, evidence of rainforest, and the geological dating placed this material at approximately 90 million years ago. 90 million years. Fine. Official story intact. Except that the sediment layers directly above this material, the transitional layers, the ones that would tell you how a lush rainforest became a frozen wasteland, those layers are oddly compressed, oddly incomplete. The transition, geologically speaking, should take millions of years and leave a clear stratigraphic record. It doesn't. Once you see it, you can't unsee it. And if you've been following the Antarctica series, links will be in the description. We went deep on the year without a summer. Not the sanitized version. Not the Mount Tambora erupted and crops failed version that history class gives you. The real question underneath it, whether that atmospheric event, whatever caused it, was the mechanism that froze this continent rapidly, completely, in a time frame that geology under the current framework cannot comfortably explain, and whether it was natural or something else entirely, something directed toward burying what was here. Burying who was here? That question is still open, but keep it in the back of your mind as we look at what comes next. Fast forward to 1960. The Japanese Antarctic Research Expedition, the JARE program, begins sending teams to establish the Showa Station on the coast of Queen Maud Land. In 1960, the third JARE expedition makes an unusual discovery approximately 60 kilometers inland from their primary base. They find an ice-free region, not a dry valley in the McMurdo sense, something different. A depression sheltered by ice walls where the ground is exposed and the temperatures are, by Antarctic standards, almost hospitable. The team surveys it, they collect samples, and then, according to internal expedition documents that were later referenced in a 1974 geological survey of Queen Maud Land, the team is ordered to record the location, collect minimal samples, and not return. Not return. The Sani Station, the South African National Antarctic Expedition, encountered something similar. In the early expeditions of the 1960s in the mountainous regions of what is now called Dronning Maudland, expedition logs describe finding sheltered valleys with exposed rock faces that show what one geologist described as vegetative patterning, striations and surface textures that, under the right lighting conditions, look distinctly like the root systems of large plants pressed into stone. Not ice. Stone. The geologist who wrote that description, and I'm being deliberately careful here not to name individuals who haven't given consent to appear in this kind of investigation, that geologist's report was reclassified, not destroyed, reclassified. It exists, it can be referenced, it cannot be read. This raises a simple but critical question. What does an Antarctic Geological Survey report contain that requires classification? Not defense secrets, not strategic military information. A geological survey of a mountain valley on a continent no nation has claimed. What exactly is in that report? I want to talk about Bouvet Island. Bouvet Island is possibly the most isolated piece of land on Earth. It sits in the Southern Ocean, roughly 1,700 kilometers north of the Antarctic coast, halfway between Antarctica and South Africa. It is a Norwegian dependency. It is almost entirely covered by a glacier. And it is, by any reasonable measure, a place that has no human history. Except that in 1964, a British naval survey vessel, the HMS Protector, landed a team on Bouvet to conduct a survey of the island's coastline. What they found on the northwestern coast was an abandoned lifeboat. An abandoned lifeboat with oars, a copper flotation device, and a water barrel. No bodies, no survivors, no ship in the vicinity, no record of any vessel having been lost in those waters in any recent maritime database. The boat was gone. On a follow-up survey, the British Admiralty investigated and found nothing. The official record lists it as unresolved and moves on. But here's what doesn't get discussed. The team from HMS Protector also documented in a separate appendix to their survey report, an appendix that was not included in the publicly released version of the survey, but which was referenced in a footnote in a 1971 paper on Southern Ocean cartographic history, the presence of ancient vegetation impressions on exposed rock faces on the island's interior peaks. Not glacial striations, not erosion patterns, vegetation impressions. Bouvet Island, as far as official science is concerned, has been glaciated for several million years. There should be no surface evidence of vegetative life at any accessible depth or altitude. And yet, The pattern repeats with unsettling precision. Piri Reis maps a coastline that shouldn't exist. Ice cores return organic material in quantities and conditions that strain the accepted timeline. The McMurdo soil is biologically rich in ways the current geological models don't adequately explain. The Jare expedition finds an ice-free region and is ordered not to return. The Sani geological report is classified. A Bouvet survey appendix disappears from the public record. Not one anomaly, not two, not three. Every time, every expedition, every continent of origin, different languages, different nations, different centuries, different scientific disciplines, the same pattern. And this is where I have to be honest with you. I started this investigation as a skeptic. I want you to know that. I came to this material, the Piri Reis map, the ice core controversies, the expedition logs, as a person who believes in the general integrity of the scientific method and the general competence of the historical record. I did not want to find a pattern, but the deeper I went, the more the individual anomalies stopped being individual. Because here's the coordination problem that nobody in the mainstream narrative ever addresses. If these anomalies are genuine errors, coincidences, misinterpretations, fine. But for them all to point in the same direction, you need a staggering coincidence across nations, centuries, disciplines, and languages. You need Norwegian sailors and Ottoman cartographers, and Japanese geologists and British naval officers all making the same kind of mistake about the same kind of material in the same geographical zone. That's not coincidence. Either there is a systematic error in how humanity understands this continent, an error so fundamental that it would reshape our understanding of prehistory, or there is something else, something deliberate. Some mechanism by which a consistent picture is maintained, while the anomalous data is quietly, consistently, reliably removed from view, not suppressed dramatically, not destroyed in bonfires or buried under black sites, just reclassified, appended and then removed, published in journals too narrow and too technical for general readers, referenced in footnotes that lead nowhere. This raises a simple but critical question. Who benefits from Antarctica being understood as it currently is? As a frozen, lifeless, geologically ancient wasteland with no human history and no relevance to any civilization before the 20th century? I'm not answering that. I'm asking it. Let me tell you about the Antarctic oases. The term oasis in Antarctic science refers to ice-free regions, areas where the combination of terrain, wind patterns and thermal dynamics has prevented ice from accumulating. The McMurdo dry valleys are the most famous, but they are not the only ones. The Bunga Hills Oasis, discovered by the American aviator David Bunga in 1947, covers approximately 900 square kilometers of exposed terrain in East Antarctica. When Bunga first flew over it, he described it as, and this is in the public record of his expedition report, a place that looked like something from a warm country. Lakes of a peculiar deep blue, red and brown rock faces, open water where there should be none. He landed. He walked on the ground, and the official history spends approximately one paragraph on this discovery before moving on. Bunga's own descriptions, his longer, more personal account of the landing, were never published in their full form during his lifetime. Excerpts appeared. The full account did not. The Shermaka Oasis in Queen Maud Land is another example. Used by both the Soviet and Indian Antarctic programs as a base site, the Shermaka Oasis contains lakes, dozens of them, some of them stratified in ways that suggest prolonged, stable environmental conditions stretching back further than the standard glaciation timeline allows. Some of these lakes contain biological communities, not just microbes, layered, complex biological communities that require sustained, productive ecosystems to develop, in a place that was supposedly frozen solid tens of millions of years ago. The official explanation acknowledges these oases and offers explanations for each one individually. Katabatic winds here, geothermal activity there, local thermal dynamics in the next case. But here's the thing about explanations. When every anomaly has its own individual explanation, and when those explanations are always local and specific and never connect to each other, and when the accumulation of anomalies across the entire continent points to the same general conclusion that Antarctic ice cover is, in some zones, far more recent than we are told, at some point the individual explanations start to feel less like science and more like management. Managing the narrative. Not explaining the evidence. Once you see it, you can't unsee it. If you're finding this series valuable, if these questions are worth asking, consider sharing this episode or becoming a YouTube member, because the more people ask, the harder certain silences become to maintain. Let me return to the ice cores, but differently this time. When you drill an ice core in Antarctica, you are drilling through time. Each layer of ice represents a year, or a decade, or a century, depending on the depth. The deeper you go, the further back you go. This is understood, this is reliable, this is why ice cores are among the most valuable climate records we have. But what happens when you reach the bottom? At certain drilling sites, Vostok being the most famous, but also Epica Dome C and WAI as Divide, the ice cores reach a depth where the ice transitions from glacial ice to what is called basal ice, ice that is in contact with the subglacial bedrock. This ice is different. It has different chemistry, different crystal structure, different inclusions, and at several sites the basal ice contains organic material, not ancient marine sediment, not microbial mats from the Cretaceous, plant material, fragments of what appear to be higher order vegetation, cellulose structures, lignin traces, and lignin is a compound found in the cell walls of woody plants, the kind of plants that make up forests. These inclusions are mentioned in the scientific literature. They are not hidden, but they are consistently framed as contamination, or as material transported by subglacial water movement from ancient deposits. The framing is always, this material is here, but it does not mean what it appears to mean. Because if it meant what it appeared to mean, if those lignin traces, those cellulose fragments, represented plant material incorporated into the ice relatively recently, in the last few thousand years rather than the last few million, then the entire timeline of Antarctic glaciation would require revision. Not adjustment, revision. And that revision would ripple outward to world-spanning sea level models, to climate history, to the dates assigned to every human civilization that developed during the Holocene, to everything. The evidence suggests something much larger than a localized geological anomaly. It suggests that Antarctica, within human memory, perhaps within the memory of civilizations we do not yet recognize, was green. Here is what a food forest is. Not a cultivated monoculture, not an agricultural field. A food forest is a layered, self-sustaining ecosystem. Canopy trees, understory trees, shrubs, ground cover, root plants, vines that produces abundant, diverse food without requiring intensive management. Indigenous communities around the world have practiced food forest cultivation for thousands of years. In the Amazon, in Southeast Asia, in West Africa, they are among the most productive and resilient ecosystems humanity has ever interacted with. Now ask yourself this question. If Antarctica was, within a geologically recent period, a continent of forests, temperate, possibly subtropical forests, with the biological complexity to develop into mature, layered ecosystems, what would those forests have looked like? Would they not have looked, over time, like food forests? Would they not have represented exactly the kind of environment that a civilization, any civilization with knowledge of plant cultivation, would have found not merely inhabitable but extraordinarily productive? The deeper I went into this question, the more another question emerged underneath it. We speak of the discovery of Antarctica in 1820, when Edward Bransfield or Fabian von Bellingshausen, depending on which national history you prefer, first sighted the continent. Before 1820, official history says no human being had ever seen Antarctica. but Piri Reis had his source maps in 1513. And those source maps, which he describes as coming from ancient charts predating the Islamic tradition, predating the Byzantine, predating perhaps even the Roman, those maps show not just a coastline, but a coastline with features, with river systems, with what may be geological markings that correspond to the kinds of features you would record if you were mapping a land you were navigating through, not merely observing from a distance. Someone navigated Antarctica. Someone walked its coast, followed its rivers, climbed its hills, and recorded what they found. When the land was green, when the rivers ran, when the forest grew, and then at some point, perhaps gradually, perhaps with terrible speed, it froze. We discussed in an earlier episode the year without a summer and the worldwide atmospheric events that may have preceded the world as we know it. Whether deliberate or natural, whether the result of volcanic catastrophe or something else entirely, the possibility of a rapid, dramatic climatic shift, one that could freeze a green continent within a human generation, is not, on its face, scientifically impossible. We raised that question and left it open. It remains open. But the food forest question adds a dimension to it, because if that land was green, and if it was inhabited, or at minimum known, mapped, navigated, then its freezing was not merely a geological event. It was a loss, not an abstract loss, not a loss of rocks and ice and academic interest. The loss of a continent, the loss of whatever knowledge, whatever civilization, whatever accumulated understanding existed in those forests. Gone, not declined, not migrated, not gradually abandoned. Frozen. I want to talk about what happens when researchers push on these questions, not dramatically, not in the way you might imagine, no midnight disappearances, no dramatic redactions with heavy black ink, something quieter and, in its own way, more unsettling. Papers get published and then don't get cited. Studies appear in proceedings volumes that go out of print. Researchers who pursue these specific questions find their funding directed elsewhere. Not cut, not punished, just redirected. A geologist who spent a decade pursuing the question of Antarctic vegetative history in the basal ice layers described the experience in a public talk that has since been removed from the hosting university's website but survives in transcript form as like pushing against something that isn't there but also isn't not there. Not a wall, not a door, something more like a current, a tendency for the institutional water to flow in certain directions and not others. The silence was deafening, not the silence of information destroyed, the silence of information that never quite reaches the room it needs to be in, the study that arrives too late for the conference, the funding application that falls just short, the expedition that gets approved for everything except the specific valleys and depths that would answer the most interesting questions. The pattern repeats with unsettling precision, and once you've seen it across enough examples, the Belgica logs, the Jarre expedition records, the Bouvet survey appendix, the Shackleton team's observations of anomalous warmth, the Bunga Hills account that never reached full publication, the SANI geological classification, you begin to understand that you are not looking at individual instances of bureaucratic inefficiency. You are looking at a shape, and the shape is not random. I want to close with a question. Not an answer. I don't have answers. I'm not sure anyone living has answers. The question is this. If Antarctica was green, if it supported forests, perhaps food forests, perhaps ecosystems of extraordinary productivity, and if that condition existed within the memory of human civilization, whether 10,000 years ago or 5,000 years ago, or in some protected and sheltered valley even more recently than that, then what does that mean for the story we tell about ourselves? Human civilization, as the official narrative presents it, emerged approximately 10,000 years ago in a handful of locations. Mesopotamia, the Indus Valley, the Yellow River Basin, Mesoamerica. It emerged from hunter-gatherer prehistory through a gradual process of agricultural development, slow accumulation of knowledge, tentative construction of social complexity. A bootstrapped civilization, starting from nothing, building everything. But the Peary race map is not the product of a civilization bootstrapping itself from nothing. The precision of that coastal survey, subglacial features that require instruments and methods we wouldn't develop for another 500 years, that is the product of something that already knew what it was doing. A civilization, or multiple civilizations, that already had cartographic methods, navigational technology, and the organizational capacity to conduct systematic surveys of a continent at the bottom of the world. Not why, not when, not under which banner, but how. How did that knowledge exist and then not exist? How did a civilization capable of mapping an ice-free Antarctica leave behind nothing we can point to and say, without ambiguity, here, this is them, this is what they built, this is who they were? Unless what they built is still there, under 2 miles of ice. Under the glaciers that advanced over their cities, their forests, their harbours, their rivers, under the weight of whatever froze them out of history. Not gone, covered. And here's where I'll leave you. The McMurdo dry valleys are still there, the Bunga Hills are still there, the Shamaka Oasis is still there. Every year research stations send teams to Antarctica, and every year those teams return with data that is processed and published and archived, and mostly fits neatly within the accepted framework. And every year there are samples that don't, data points that are noted and set aside, survey results that are filed rather than followed up on, individual researchers who return from the ice with a look in their eye that their colleagues have learned not to ask about, not because they're hiding something, because they don't have the language for it yet, because what they saw doesn't fit any available framework, and the frameworks we build to understand the world are also the frameworks that limit what we allow ourselves to see. Once you see it, you can't unsee it. Antarctica was green. Once, perhaps recently, perhaps in ways that would rewrite everything. And somewhere under all that ice, under the cores and the surveys and the reclassified appendices and the expedition logs written by men who came back changed, the forest is still there, waiting.